Welcome back to COG 376. Today, our last day, we're going to get a little bit of hands-on with the big, beautiful, strange system GPT-3 that we talked about right at the start of the semester. So first, let's lead off with a little example from the website AI Dungeon. It's a adventure writing system, text-based adventure, but it's all written by GPT-3, absorbing context and then emitting words. Let's look at my example. You are Dr. JKL, a peasant living in a small village in the kingdom of Larian. You have a pitchfork and nothing else. You dream of getting out of your village and having an adventure. You go to your fields to begin working. You look up and see the clouds beginning to look angry. The village blacksmith runs up to you and hands you a letter. That was all the prompt. That was all what the system prompted me with. It's more or less the same, not always the same, but these are pre-baked. I didn't write that, and neither did GPT-3. I wrote, open the letter. What I'm saying to the system is, this is the next line of the story. What the system then goes on to do, it writes me a letter, something that it invented whole cloth to invite me to be on some kind of mythical team called Mythical. It's an invitation to adventure. It wrote every word of this, written entirely by a neural network, one word at a time. You can pause to read more of it, but the point is that this is all language generation from this model. So, what is GPT-3 and why is it so dang good at language? Let's find out. GPT-3 is Generative Pre-trained Transformer, version number 3. So it's a model that generates language. It's pre-trained, as in anyone who's using it and providing it information are not actually training it. It's not going through any, neural network training type things. We just submit text to it, and it can emit text back at us. It's capable of transforming information it receives, not just regurgitating things that had exact patterns that it's found. We'll talk about that in a second. And this is the third iteration. GPT-2 came out in 2018. They pretty quickly developed it into GPT-3. Things are expanding rapidly. So first, what's this transformer idea? So this is all based on the transformer that came out, another language processing tool. It is a deep learning, recurrent neural network that's designed to take in sentences all at once. They have this feature, which you also have. We can refer to it as in the same context as attention. So it's this idea that you can focus on relevant parts of a sentence and extract meaning from it, not linearly. You don't have to read every word one after another, but sort of all at once. Now, whether that's exactly how we do it, probably not. But there is this element of a whole sentence is easier to make sense of than one word at a time, right? So you may read one word at a time, but once the sentence is in, you start working on it as a whole, potentially. So this is really appealing to this, this large scale model world, because it means that the process is parallelizable. I don't have to, like in the neural networks we looked at before that can generate language, they don't have to go exactly one word at a time for the input. They can do this sort of parallelized thing. They can leverage the computing power of things like GPUs and do a lot of math all at once instead of just waiting for each one at a time. That difference between parallel versus linear is huge when it comes to creating something gigantic. So, what at the end of the day is GPT-3's fundamental job? At its most basic, it's kind of similar to what we've seen before. It's next word prediction. That's really all it was doing. That seems crazy, but it's the same process that we've seen in n-grams, context vectors, the other neural models we talked about. They're all doing the same thing. They're coming up with the highest likelihood for the next word. So in a sense, this is just text completion, right? Like we've seen. The difference is that what the models are learning. N-grams are capturing basic local statistics. Context vectors are trying to get these co-occurrences that are nearby in these bag of words models. Neural networks are doing something a little more complex. And at the end of the day, GPT-3 is primarily a neural network. So, what's it look like? So, GPT-3 is touted as having a boatload of parameters. Parameters of any model, not just neural models, but they're the things that are the adjustable parts, right? In our n-gram models, we had all those word pair statistics. We would say that the relationships between those words were parameters. Same for the context vectors. They each cell of that co-occurrence matrix of, well, here's a word and here's all of its co-occurrences with the dictionary, right? That's also a co-occurrence. Those are both examples of parameters. In neural networks, remember, the things that get updated and changed in a neural network are, by and large, the weights, the connections between nodes of the neural network. And remember, we talked about backpropagation. You can run back and change them and reiterate them and all these great things. The thing with GPT-3 is that it has 175 billion parameters, 175 billion weights, connections between nodes. Now, this is a little historical plot of large language models that have been coming out in the past few years. Oh, I was wrong. BERT Large is the 2018 one. 355 million parameters. GPT-2 brought in 1.5 billion. T5 came out in the competition, 11 billion parameters. And then GPT-3 leapt forward again, another factor of 10 into 175 billion parameters. That's a large number. It's hard to get your head around. All to be contrasted with human brains. We've got about 100 trillion is the thought, somewhere in that realm. Because you have 10 billion neurons-ish, each node, right? And then each one can be connected to up to 15,000 other neurons by its huge networky dendrites and axons. So, that's the parameters. This is what the model is doing. It is just a giant neural network, but it has a boatload of connections and layers. It's training. So GPT-3 was trained on 499 billion tokens. Now, we've talked about tokens. That is words, right? And they come from various places. 2 different book databases, so published works. Comes from Wikipedia, so lots, 3 billion tokens from Wikipedia, so at least there's that sort of collective knowledge baked in there. And it's also just done a huge crawl of random internet stuff. Now, they do say it's filtered by quality. Who can say for sure? It's unclear what quality means at sometimes, but the point is that GPT-3, its language corpus, so it's a huge model, and it's got this huge corpus of data that it's been churning through. Now, there's a reason that there's a P in the title, pre-trained. Let's talk about the training of GPT-3. GPT-3, it takes up, just to store the damn thing, takes up 700 gigabytes of space, meaning that every time you do something and you may have to update weights, you may not have to update all of them, but you're updating a lot of them. Every shot of learning, every bit of learning it does has to interact with that much data. You may say, oh, I have a terabyte hard drive. Yeah, well, imagine if every step of your program that you write had to access your entire hard drive, right? So to do this thing, process these 500 billion tokens with a network that has 175 billion nodes in it, or rather weights, connections, parameters, that's 314 sextillion floating point operations. Floating point operation, by the way, is just like a basic unit of math calculation in your computer. It used to be, I forget what they do, bytes per second or whatever, but that doesn't matter as much. Hertz, right? what matters is whether or not you can do a floating point operation, these arbitrary precision numerical things. So, aside, that is a lot of things to do. That is a lot of operations to achieve. So even at 28 teraflops, 28 trillion floating point operations per second, comes down to that takes 355 GPU computing years. As in, if you turned one GPU on and said, hey, do this thing, it would take 355 years to do it. You did that in parallel, of course, when they trained this model to begin with. But when you just run the operation costs, the electricity costs of building this damn thing, it's $4.6 million just for a single run of training on the corpus. Like I said, there's a reason it's a pre-trained system and not something that you're able to just arbitrarily shove new learning material into. So, why is it good, though? Why is it worth all this effort? It's huge, sure. It's complex, sure. What are we getting for our $4.6 million? So one of the tricky things that GPT-3 can do is it can abstract a lot of things. And that's because, so when you think about most models, they need to be tuned to a particular task, right? Think back to the Rumelhart-McClelland model. Verb tense transformation was the only thing that model could do. It wasn't designed to also, count to 10 using language. It didn't have that capacity because it didn't have any nodes for such a thing. It was a rudimentary model. Even though it was complex, it was cool. Like we recognize that it's good. It was a good model, but it was trained for one thing. GPT-3, it just scales up the complexity. So the big thing that helps it do more abstraction is it's a deep learning network, meaning it contains a lot of layers, extra layers, right? More and more layers helping to do increasingly abstract concepts. On top of that, it is recurrent, meaning it's able to do this really important attention stuff. So while it's able to, it has a lot of complexity baked into it, it's also able to sort of filter through its own complexity. So those two ideas, again, we come back to the idea that this is freaking huge. It has space to capture a huge number of nuances in the structures of language that are difficult to describe, and even go above and beyond that to find things like processes. So think, just as a point of reference, think back to the Rumelhart-McClelland model. We had the feature level information comes in to the bottom layer of the network. Then the letter recognizers come in and they start recognizing things. Same with the phoneme recognizers. You get up to the word level recognizers that say, I know that word. You can keep going. When you are a deep network, you can continue. So sentence recognizer might come into play. And then above that might be a set of structure recognizers. And then concept recognizers, things that understand abstract concepts in ways that we can't totally define because we just let them train themselves, right? Relationship recognizers between concepts, process recognizers, exploiting relationships to, all these things that brains be doing. You can imagine that a neural network system that is sufficiently deep and wide like this, it's able to adapt some of that. Not all of it. Again, human brains are bigger and more clever and more interesting, but still, the neural network of this size can do some really interesting things when you let it go. So, what is GPT-3 capable of? Again, altogether, it's just big, right? It has this incredibly large corpus. It is deep with a huge number of these weightings between nodes, so it can pick up a very large number of abstract relationships and interactions from the language that it has studied, all captured in the weights between those nodes. But primarily, its key power is this filter and focus stuff. So normally training on everything would make a model behave a little bit spottily, right? When I trained that, my Ngram model on the kids babbling versus Dr. Seuss and mushed them together, it didn't really come out with anything coherent. It was kind of goofy and fun to read, but it was not really, it sampled from multiple sources and it got a little bit weird and plain. It didn't always know what to say next. But the trick is you train this system on so much stuff and give it so much capacities, but then you give it the ability to filter. So when you give examples to this system, it helps it activate, oh, this is the kind of task I'm working on right now. I didn't know that before I saw this example that the person wrote into the context that they submitted to me, but now I do. So that's the idea. This is the idea of being able to predict these more appropriate outputs from the gigantic space that it lives in by being able to filter using its recurrent nature. So that brings us to this key, almost marketing phrase, but it's good, few-shot learning. You may have heard of one-shot learning. It's like when you eat something and it makes you sick, you learn that pretty quick. It's one of the only things that works. Normal learning takes a long time. You have to see lots of examples, it starts to click, etc. Few-shot learning is this trick that GPT-3 is doing, is it takes these examples as context. It is not training based on the examples provided to it. Remember, the training is expensive and it's done. What makes this thing so flexible and powerful is that when you give it examples, it draws from the right areas of its network. So it helps it activate the abstract parts of its network that allow it to quote, get what you're aiming for, similar to you. For example, what if I said this? What is a dog? That's a weird question. There's a lot of ways to answer it. You're not sure what I'm trying to get at, right? It's sort of a loose concept. What is it? Well, it's an animal. Well, is that good enough? Is that specific enough? Is that what you meant? I don't know. It's not clear. There's not much context. Even though I have a huge brain full of all kinds of good information, I'm not really sure what you're looking for when you just ask that question cold. Imagine if you received this in an email from me with nothing else in it, right? That's nothing. Provided an example. What is a bird? A feathered animal. What is a dog? Well, now you might know a little bit more about, oh, there's a format that they're looking for here. Maybe they just want to know what they're covered in. It's a furry animal. And then I would say, yes, thank you, good work, yay. Because that was what I was looking for, was this sort of the definition. Even though I underspecified the question, providing an example allowed you to start to draw that inference. You may not still have gotten it, but this is just a toy example to illustrate. So this is the idea. You activate context by providing examples, and the system is able to then pick up, oh, I know where we're talking about. I know what we're talking about now. I can produce language. So this is really interesting because this means, in a sense, that you don't have to make a special kind of task for the system to really literally understand. It already understands a lot of tasks, pardon me, that because it's studied so much information, it's studied so much text in the world, that it's been able to draw these crazy inferences about, oh, I understand structures and formats and all that. And again, it can't speak to that. It can't say, thank you, human, I understand structures and formats. The point is that it can wield them. So you can provide it a task to help it understand, oh, that's what we're doing. Okay. And you can send it to the model to help activate its context. So, for example, when you send GPT-3 something, say you're trying to get it to translate French or English to French, right? If you can speed up its ability to understand what you're talking about, or rather not speed up, but focus. It might give you a random answer if you did something like cheese, arrow, bracket, right? If I just did cheese, arrow, bracket with nothing else, it would be like, what are we doing here? But if I provide the examples, translate English to French, and peppermint, arrow bracket, menthe poivre. I don't know if I said that right. That's giving it context. It's activating systems that say, I know the mappings between these things. I know what task we're talking about here. And all of its things that are related to French words and English words and the transition between them, they all start to light up and increase the likelihood that, if they say this, then the most likely desired word is going to be the French version of the one on the left side. Cheese becomes fromage. So we're getting at how a lot of this works. We can look at some examples that are fun from the authors themselves. So the authors in the OpenAI Foundation who are developing this, they wrote this paper on it with a little bit of interesting research going into it too. We'll get to in a sec. So things that GPT-3 can do. News article generation. It's able to do some really powerful news article generation that's a little bit scary, actually. So here was the prompt to this one this was the most confused article in this study. So the system, you gave it the title, United Methodists agree to historic split, subtitle, those who oppose gay marriage will form their own denomination, article : nothing. All the bold text is what the system generated thereafter. Humans had a hard time spotting this as a fake. It's doing a good job. It's mirroring the kinds of things you see in actual article writing. It's even sort of backing itself up a bit. Now, the odds are good that you could find, if you Googled certain segments of this, you might find specific things that were, learned from the internet. But the idea here is that it is able to produce this really good-looking information, this really convincing article writing. On the flip side, this is the one that fared the worst. 61% of humans were able to spot this fake. Stars Tuck's promise draws Megyn Kelly's sarcasm. Subtitle, Joaquin Phoenix pledged to not change for each awards event. Article. Okay, here we go. A year ago, Joaquin Phoenix made headlines when he appeared on the red carpet at the Golden Globes wearing a tuxedo with a paper bag over his head that read, "I am a shapeshifter. I can't change the world. I can only change myself." Go on and on. It becomes this gossipy, Hollywood rag article. And the fact is, I actually read this once. And I had to Google this. And it turned out it led me to articles about GPT-3, not an actual scenario where Joaquin Phoenix wore this "I am a shapeshifter" bag on his face. Consider me fooled, but I just prefer to live in a world that's bizarre. So, but the point is that even in this worst case one, look at it, just read it. It's very good. It reads like real journalism. It's not like fumbling over every third word and showing its edges and stuff very clearly. Anything that it does make a mistake on, it's doing it at about the same rate as people do, which makes sense. It was trained on people. So here's a chart they show us of the accuracy of predicting whether or not this is a false article, like a generated article, with the number of parameters. So as the parameters go up, the ability to detect them goes down. And that's interesting. That's cool. That's a little scary. I think it has to be all of those at once. And I encourage you to think about the same. Let's drift away from these spooky thoughts and into another weird thing it can do. So GPT-3 can also learn new words in one shot, in few shot learning. For example, a watpu is a small furry animal native to Tanzania. An example of a sentence that uses the word watpu is, "We were traveling in Africa and we saw these very cute watpus." Notice that they've included the proper plural there too. Okay, so to do a fardoddle means to jump up and down really fast. An example of a sentence that uses the word fardoddle is, and then we let the system say something. So we're showing it what it can be like to adapt a new word to a new situation. And what it does is, one day when I was playing tag with my little sister, she got really excited and she started doing these crazy farduddles. Whoa. It just realized that the task at hand is take this word and reuse it in a sentence that makes sense based on the context activation from the sentence above. Farduddle means to jump up and down really fast. It went and found a sentence that makes sense where somebody might jump up and down really fast, and it slotted in the new word. A yalubalu is a type of vegetable that looks like a big pumpkin. An example of a sentence that uses the word yalubalu is, I was on a trip to Africa and I tried this yalubalu vegetable that was grown in a garden there. It was delicious. Didn't really get at the pumpkinishness of it, but it still figured out that, oh yeah, pumpkins grow in gardens. People grow their pumpkins in gardens. Here we go. So this is what we're seeing here. It's able to adapt these concepts on the fly because it has so much information encoded in it about sentence structure, concept relationships, all of this stuff. And remember, it's all black boxed. We don't have direct access to all the concepts that it has learned. We just know that it has learned them when they emit language like this. Another one that they show up is correcting English. So I ate the purple berries becomes I ate the purple berries. Thank you for picking me as your designer. I'd appreciate it. Thank you for choosing me as your designer. I appreciate it. The mentioned changes have done, or I did the alteration that you requested, or I changed things you wanted and did the modifications. That's a lot. The requested changes have been made, or I made the alterations that you requested, or I changed things that you wanted and made modifications. So these are all of the input. These are all the things that you're doing to train it. You're saying, hey, give this a shot and start taking new inputs. So finally, it gets to the translation of, I'd be more than happy to work with you in another project. I'd be more than happy to work with you on another project. It figured out, oh, in and on, those are improper. I should swap that. Then we get things like, the patient died. Janet broke Bill on the finger. Janet broke Bill's finger. That's a pretty interesting translation, right? You would be hard pressed to just sit down and write a good, syntactic generative grammar transformation between Janet broke Bill on the finger, this obviously busted sentence, to Janet broke Bill's finger. Human person can obviously do that. You can infer, I think they probably meant this. But that's a tough translation to form. It's really fascinating. So that brings us to my role in all this. GPT-3 is carefully guarded, and probably for good reasons. It's expensive to run. It's pretty powerful. I mean, you don't want to give everybody access to a thermonuclear device, right? So access to their API to interact with GPT-3, with this trained model that lives on their servers, it usually takes months on a waiting list, and even then only with a good pitch for what you actually plan to do. But through a collaboration with an old colleague, I managed to get access. And I messed around experimenting with it, and I can show you some of what I found. Let's look at it. First of all, here's the interface. This is their API. It's just a website. You can also do API calls through normal, URL type fetches and things like that. But in this case, this is the system, and you can send it different parameters. You say, hey, here's what I want to get back from you in terms of length, how much processing you should do on it, what certain sequences might mean. But altogether, ultimately, it is just send it a text box. Every different interesting thing that you want to do with this system is written in regular human language, regular natural language. You don't say, I'm switching you into categorized data mode. No, you just tell it, categorize this data, please. You don't even have to say please. Maybe it's nicer. Who knows? So let's look. First, we're going to roll back to that example that I gave. Trying to get the format a blank animal where the blank is what the animal is covered in, right? I'm going to do the same thing to it that I did to you. Here's the context. Answer the questions. Q, what is a dog? And the system says, a dog is a four-legged animal. Like, nah, that's not what I'm talking about. Come on. So I give it a little more context. Answer the questions. What is a bird? A feathered animal. What is a dog? Mammal? So at least it is shortening its responses now. It's come up with a more categorical thing. Maybe a single descriptor is what we're looking for, not a set of words describing a thing. So, still not quite there. Context. Let's continue. Answer the questions. What is a bird? A feathered animal? What is a fish? A scaled animal? What is a dog? A canine animal? Again, it's sort of circling the same space. It's saying, we're trying to get at some classification, but I'm not sure what, right? More context. What is a bird? A feathered animal. What is a fish? A scaled animal. What is a cat? A furry animal, right? The dog, it's like, well, I don't know, a single descriptor. So not a categorization, but a thing that it has. A mouth? It's a mouthed animal. Still not quite there. What finally tipped it over the top in my experimentation was I changed the prompt itself a little bit. I added the idea, answer the questions about the properties of the skin of an animal. Again, the point of this is to activate the context in the neural network that says, oh, I see what you're trying to get at. You want a furry animal out of this. It's a little journey we went on. I liked it. I think it highlights some of the ways that it can be shaped by examples, but being more explicit in the task description might help it even more. Not clear. I can't tell you what's going on inside, so these are just my thoughts, my hypotheses on this, but fascinating to work with. Parsing unstructured data. So here's this one. This is actually an example they give. I'm just going to walk through it because it's fascinating. Extract some information from natural language and put it into a table. So here's the context. There are many fruits that were found on the recently discovered planet Gukrux. Again, random false words, but it's able to wield them in different ways. So there are neoskizzles that grow there, which are purple and taste like candy. There are also lohekels, which are grayish-blue fruit and are very tart, a little bit like a lemon. Ponets are bright green color and are more savory than sweet. Ooh, 2 descriptors. Interesting. There are also plenty of loopnovas, which are neon pink flavor, and taste like cotton candy. Finally, there are fruits called glulls, which have a very sour and bitter taste, which is acidic and caustic, and a pale orange tinge to them. Here comes the task. That's the background information we've provided to the system. Please make a table summarizing the fruits from Gukrux. Fruit color flavor, separated by pipes. And one example, neoskizzles are purple and sweet. Interesting. So we have given it the example, candy means sweet. Remember, find the flavor of the thing that it was compared to. So let's see. How does it do on each of them? First of all, you notice that it's keeping the format, which is great. It does the pipes and does the words, right? Lohekels is the second one. We know they're grayish-blue color, and they are very tart. It skips the part about lemon, which is fine. Ponets are bright green color, okay? And it picked savory because it's more savory than sweet. Interesting. There are plenty of loopnovas, which are neon pink flavor. It decided pretty quick, like that is a mistake. That's not what a thing can taste like. That is a color very clearly, so it slotted that into the color pile. Whereas cotton candy, it just left that as it is, because we didn't talk about what cotton candy tastes like. And finally, glulls, it does stumble here. It doesn't know how to extract the color from this one. In fact, it tries, it's like sour and bitter taste is the first thing it found, and then acidic and caustic is also flavor. It did what it could. It dropped the ball. Not exactly sure how and why, but we can tell that there's, it's maybe juggling too many descriptors. The fact that it's already done some interesting inference over the other ones, like correcting errors and selecting things based on, strength. Woof. Like I'm talking about, these are the ideas that it has the ability to preserve these interactions and relationships in its system. Just a neural network. Finally, classification and categorization. So try to classify new information in a similar way. So here's one. The following is a list of animals and the categories they fall into. Dog, canine, mammal. Cat, feline, mammal. Wolf, lupine, mammal. I say then to it, tell me capybara. It's like, I got this. Rodent, mammal. But then, I just told it to keep going. So I extended the context now to just include the output it sent and the input that I've given it. All of this now becomes the new context for a new iteration, and it just goes right on and invents something new to put in the table that fits. It's like, what about rabbits? Those are lagomorphs, mammals. That's correct. Include that in the context. Produce me something else. It says rats. Those are rodents, mammals. Now, it did never stray outside of mammal, but, we'll see. We'll see if it's something it can do. But that's fascinating. It's able to sort of keep, it's like, I get it. I get what we're doing here. I'm just going to keep adding things that make sense to add. Woof. Powerful stuff. So, this has been our hands-on. We see some interesting things here. Some things activate context better than others, right? The more explicit the task prompts are, seems to help it, rather than hoping it infers the right patterns from your examples. So that's fascinating. You get to tell it in plain English what you want it to do. Oof. It's also very capable when it comes to restructuring data in an unstructured prompt. It gets a little confused when there's too many potential descriptors, but still, it's able to just say, yeah, I'll write the table for you. That is something uniquely powerful. And it can categorize information fairly easily. It's happy to continue building on to its own prompt and just keep going. I got more. I got more in me. Don't worry about it. We got this. So, that's GPT-3. It is a massive 175 billion parameters and neural weightings, pre-trained, took hundreds of compute years and over $4 million to train, deep learning, lots of layers capable of tuning to a very abstract concepts, recurrent neural network capable of focusing attention on particular elements of the context, designed to produce language one word at a time based on likelihood, essentially just like n-grams on context vectors, just way better at it. Now, GPT-3 as a language model, I'd say this thing gets a whole hell of a lot right. It rarely flubs parts of speech or grammar. It tracks concepts. It can properly reference them over duration. It can infer meaning of new words. It can flexibly change the format of information, remembering proper delimiters and things like that. Anything that I understand from language, this thing is doing a lot of it without any hiccups. Now, all in all, it's a huge success, right? It's capturing a great deal of how language is used, but it still is kind of just a mimic in a lot of ways, There are times it may run itself into a corner, and no matter what you feed it, it just keeps harping on the same story because it doesn't have, it's sort of in a lightly studied area where it's overfit itself. So, and really importantly, the big thing is that remember that this is a neural network, so we will still always struggle to extract meaningful information from its black box. It's just numerical weightings between nodes. None of them are labeled. It doesn't know how to express what's in its nodes any more than you know how to express what's in your nodes. Now, a different angle, GPT-3 as an artificial intelligence, it demonstrates itself as a pretty capable AI here. It's obviously passing the Turing test much of the time. It can perform a lot of interesting tasks. It even exhibits some small forms of creativity, right? Giving itself new prompts. That's really cool. But it's also unclear how robust any of its reasoning actually is. Remember, it's designed just to reproduce language. It's not designed to have higher order, cognitive capabilities. Say, oh, well, my meta process says that my memory says that this thing's not real because this evidence was, it doesn't have those kinds of systems explicitly, right? It could have some of them to an extent, but it's not clear, right? All in all, though, it's encoded a lot of information, so it is a pretty powerful information wizard. If you ask it, who is Batman, it'll answer Bruce Wayne as long as you've given it the proper context around it. But you got to remember that it's extracted all of its training from the internet, which means that while, you're getting things like Wikipedia, you might also be getting things like Yahoo Answers. Rest in peace, you sweet, stupid monster. The internet is a darker place without your brilliant, dumb light. So, that's it. I'm going to leave you with two things this time, here at the end. First, a near final thought. As always, I want you to think about these kinds of things. GPT-3 is powerful. We see some of the edges of that power. Certain things it struggles to get right, rotten things it may internalize, things it gets confused about. Consider that it has, nevertheless, become so robust in terms of its ability to track concepts and even grammar that it's becoming difficult to distinguish it from human writing. Weigh in your mind the costs and benefits of sharing this technology with the world. Is this dangerous? Revolutionary? Both? But also, GPT-3 is hard to get at, right? You don't have direct access to it usually. It's hard to gain access. You got to, propose an academic reason for it. But for now, if you want to mess around a little bit with certain versions of GPT-3, go check out AI Dungeon. It's the thing that generated that text at the start of this lecture. It's highest performing model, like the one that has the most parameters. They're gonna make you pay for that one, but the lower tier ones are free because they take way less energy to run. Hard to blame them given what we've talked about this, and you can go to see their cost update on the topic. But the idea is each entry you submit is going to prompt the system to generate some more text. The context of each submission includes everything written so far in the story, among some other things. Some other things get into the context, like if you do one of their worlds, it always has the world prompt somewhere in its submission text, which is good. I mean, that makes sense, right? We've seen how it needs to have sort of something to keep it active with the current thread, right? So it's able to mostly keep track of a lot of the narrative information. It's pretty fun to mess around with. But the word to the wise, this thing's been trained is almost entirely on like fiction writing. This particular one is focused on the worlds of fiction that have been gathered up. So just know it can get a little bit violent, raunchy, messy pretty fast, my dudes. So consider yourself warned. And if you're sensitive to that kind of stuff, just angle away from it in your interactions with the tool. If you lean in, you will be quickly in a world of hot garbage. And maybe that's your thing. I don't know. I ain't here to judge. But the thing I want to leave you with finally, the final thought is I'm just going to let this play. I messed around with the tool for about 20 minutes with AI Dungeon, and I just had a little conversation with the system. You're welcome to watch the entire thing or just watch enough to get a flavor of it. But either way, that's it for the semester. Thank you so much. It's been a pleasure.